So in this video today, we're going to talk about vectors in 2 dimensions. We eventually do a vector in 3 dimensions for keep, but that time will come as yet. We in 2 dimensions for now. So let's see. I have an x and a y axis or a Cartesian view. Right? Wanted a straight. Let me try my best. Okay, yeah, perfect. As the Germans would say, perfect and schlag. So we know from usual coordinate geometry, call it y, call it x. Well, we could define any point on this plane in terms of, like, let me say here, let me just say, for example, here was 5, here was 2. So this point is defined by the coordinate 5, 2. Now everyone should be familiar with coordinate systems like this. It's called the mathematical term. I know most of you all may not have heard this, but when you represent coordinates like this in an x and y, it's called an n-tuple. N-tuple, but forget about that. That's just precursor to tertiary level things that will be coming in our timing. So we have a x here and we have a y here. So this is one way we could think about defining any point on this plane here. But vectors now, vectors considers this point of view. So this point here is the origin, the point 0, 0. Sorry about that. Yeah, so here's the origin. So a vector would say, we would define the point as such, like a line from the origin to that point. Think about it this way. It come like you move 5 units in the x direction and 2 units in the y direction. It's analogous to coordinate geometry as highlighted here, but a vector considers a line starting at the origin to a point. This is a specific type of vector called position vector. There's a general definition of a vector where it's like a mathematical definition. We will get to that soon, but when you have a line starting from the origin to a point, we call that a position vector. So we could have called this point here P. So in vector form, we would see origin to the point P, and we put a little arrow. And also, in vector, we could use some variable, let's call it A. Sometimes you would see A with a bar on top or A with a bar below. It's all mathematical notation for the same thing, but this notation here with the arrow is the one I like to use the most. So let's define a vector. It's something with a size and direction. This is the definition of a vector, because if you think about this point here, like it would be some distance away from your coordinate system, or where yes, your reference for your coordinate system was maybe some distance away from that point, and it's some orientation relative to this point here. So it's something with a size and direction. People who do in physics can eat up this definition. They know exactly what I'm talking about here, but I'm trying to explain this to people who don't do physics. So like think about it as something with a size and direction, and also you could think about it as representing movement from one point to another in a straight line of some length and some direction. So this is like a way to generalize the notion of a vector. So like we could say the point P, which is in terms of Cartesian is 5, 2, and in vector form it's expressed as follows: 5, 2. X coordinate here, Y coordinate here. Now this thing here is called column. Pretty sure I spelled column wrong, but close enough. Column vector notation. So any point on the Cartesian plane, X, Y could be represented in column vector notation by just rewriting it like this. When you put it like this, it's understood you're talking about a vector. It could be a position vector, where a position vector is a vector from the origin to a point, and well, vectors is movement from one point to another in a straight line of some length and some direction. So let's look at the operations on vectors. By operations we mean addition, subtraction, multiplication, and luckily there's no division in vectors at this level. So by now you guys know I use Paint for this. Paint is the best graphical interface software. I don't care what no one says. Until you have a proper tablet and you try it for yourself, you would never look back. And no, I'm not sponsored by Microsoft. I wish though. I wish. Okay, so let's look at operation on vectors. So let's say we are given the vector okay, let me draw this. Let me draw something. So this is P, this is Q. So we are given the vectors O, Q, and OP. Let me assign some numbers to this. So this here would be, let's say it's 1 and 5, and let's say here is 5 and 2. Like, I just put it in column vector notation to show that I'm dealing with vectors. So we have OQ, which is given by 1 and 5. You could think about it moving 1 unit in the X, 5 units up in the Y direction. The signs indicate whether you're moving in the positive or the negative directions, up or down, respectively, for the X and Y. Now the OP is 5, 2. So let's look at how do we get from Q to P. So how I think about vectors is like, imagine like you have a fixed path or a fixed road that basically connects at, as shown here, like two fixed roads that just start at one point and branch out from each other, right? So if I'm at Q and I want to get to P, I will have to go from Q to O, but that's opposite the direction of my position vector OP. So I would say negative OQ. Now plus, since I was at Q to O and I say negative OQ, now I'm at O, I would have to add OP. And this is simply done by just adding the corresponding X and the corresponding Y's. So minus OQ would be minus 5, minus 1, and plus OP is 5 and 2. So we would get minus 1 plus 5 is minus 4, and minus 5 plus 2 is minus 3. So how do we interpret this? So from Q to P. If you were to draw this on graph paper, you would notice to go from the point Q to P, you would move 4 units down in the Y direction and 3 units to the left in the X direction. Now this is not drawn to scale, but the math behind it is of essence over here. So let us do P to Q now. Oh, just note here, this could have been rewritten as OP minus OQ. So show your addition and subtraction here one time. It means the same thing. So P to Q. So if we are the fixed road OP and we are the point P, that means we have to go from P to O. So it's negative OP plus OQ. Let me color code this example. So negative OP is negative 5, negative 2, plus OQ, which is 1 and 5. So you will get the vector P to Q being negative 1 plus 5 is negative 4, negative 3. Which is what you would expect, because it in one way from Q to P you went here and you're going back here, so you would expect some sort of similarity in terms of the movement as I was explaining before. So this is addition and subtraction of vectors here, and it had something here like where with the negative and I multiplied the, like look here where I say negative OQ and I just put minus 1 and minus 5. That is something called scalar multiplication. So scalar multiplication is defined as, so if k is a constant and you have a unit vector of the form xy, you just say k by x, k by y. So it was minus 1, so minus 1 by 1 is minus 1, and minus 1 by minus 5 is minus 5. That's what I used here, scalar multiplication. So from memory, this is it for vectors with maths. The questions is be a bit more tricky and require a bit more thinking, but this is the essence of what you need to know for maths. Now for ADDMATHS, I would do a vector video to continue the theory that the math students don't need to know.